All right. Hey, thanks for joining me for a minute. Let's take a look at a pyramid real quick. And I will say right away, if you have not really looked over the prism first, the one where the top and bottom are identical, I would really request that you go back and take a look at that before you take this one on, because it does get a little bit harder when you deal with a pyramid. So off we go. So we have a pyramid right here. So in this particular case, what I have is a pyramid with a pentagon base. So this is called a pentagonal pyramid. Now, again, what we do with these problems, I would say first and foremost, it's really important that we go through a little bit of a process of finding some things that we have. Little anatomy lesson, if we will. So the base right here is this pentagon that's the bottom. We also have a height right here, which for this particular problem, I think I decided I'd make the height something like, say, 12 inches. Nothing particularly important. And let's say the base length right here is 6 inches, which is going across the bottom of this triangle. But interestingly enough, there's a few extra little pieces that go into this. One is we want to find, for example, if you look at this, I would like to find something about this triangle that makes up the base right here. Now, this is very similar to what we did in the previous one, is I need to find out information about that triangle, which is laying down in the base of that figure. So the first thing I'd like to do is find out what is the area of that base. But of course, to find the area of the base, I need to find the area of the triangle. So let's figure that out. Now, what I know right away is that if this whole side length is 6 inches, then of course, this piece right here is 3 inches. And if we do the same thing that we did before and we take 360 and we divide it not by 5 for 5 sides, but the number 10, I'm going to double that because I really didn't make a triangle that takes up the whole side. I only took up half of the side. So I know that this angle here at this base is 36 degrees. Now, similar to what I did in the previous example, I went ahead and I use the fact that there's 180 in a triangle. So I took 180 in the triangle. I took off the 36 that I gave you right here. And I took off the 90 for the right angle that we use when we deal with these kind of problems. And I found out that this other angle over here is 54 degrees, okay? Now that I have found that to be helpful because now I could say that the tangent of 54 degrees is opposite over adjacent. Remember SOHCAHTOA. That's why these problems can be considered hard as you have a lot of math to deal with. So if I were to take 3 and multiply it by the tangent of 54, I would find that the height of this particular segment is 4.129 inches. So that would mean that the area of this triangle is 1/2 the base 3 times the height 4.129. So the area of this particular triangle is 6.194. But the cool thing is that means I could find the area of the base, the full pentagon, by simply taking that triangle and multiplying it by 10, because it would take 2 triangles to make up the whole thing and then 5 of those to make up the entire base. And so the base is 61.935. Well, that's the first part. Okay, so now finding the volume becomes trivial. Now, this is a little bit of a surprising formula. It's not what people normally think, but it turns out the volume of a pyramid is 1/3 the area of the base multiplied by the height of the shape. So that would be 61.935 would be the area of that base. That's what I spent the most time of this problem doing, times the height, and the height of the shape is 12. And of course, there's little things we could do in math that go fast. I could say that these cancel out to leave the number 4, because 3 goes into 12 4 times. So I'm just going to multiply by 4. And I got that the volume of my shape is 247.74 cubic inches. Oh, I said feet. I just realized that. This should be inches cubed, right? That's inches cubed. And I guess this one up here should have been inches squared. Now, okay, so ironically, that was the easy part. Now here comes the kind of tricky part, is I want to find the surface area, which means I need to attack this in such a way that I could find the area of this right here. So if I could find one of these pink triangles right here and multiply it by 5, then I would find what we call the lateral area. All of these sides coming up form what we call the lateral area. That took longer to color that in than I thought it would. But what we can do, though, which is kind of interesting, is I need to figure out what we call this right here, which is called the slant height. And unfortunately, I don't have a lot of information about that slant height because all I know about it as it currently stands is that it goes across by 6, but I don't know how tall it is. So this is the tricky part of this problem, is that if you were to connect this up, we have a three-dimensional right triangle right here. And although the picture is a little deceptive because of all of that stuff, the distance from the center to here is the same as the distance to all of these centers. So I already figured out that this distance right here is 4.129. So what I can do is I could use the Pythagorean theorem, and I could say that 12 squared plus 4.129 squared is equal to c squared. So I would need to take the square root of this number to find that hypotenuse. So I found out that the slant height, or the hypotenuse, is 12.69. And now we are ready to go. We are ready to go. So let's find the surface area. And that would be 5 triangles. But every one of those triangles is 1/2 its base, and the base is 6, and its height is 12.69. And in addition to the lateral area, these triangles are coming up, I also have the base, but I already figured that base out. And so here we go. So we're going to get 12.69 times 6 divided by 2 times 5 plus 61.935. And I found out that the surface area would be 252.29. And again, everything here was measured in inches. So the surface area would be in inches squared. Hey, that hopefully didn't take too long. Hopefully that made sense, but I do know that's pretty tricky because you got a lot of angles going in different directions. So again, thanks for taking the time. I'll see you back in class. Bye-bye.